Okay, so this video is about integration by recognition, and it's also, we're going to talk about what to do when the integral is so hard that you have no rule to understand. Okay, our learning intentions, we're going to find the antiderivative of one expression by first finding the derivative of a related function. And we're going to use our CAS calculator to find the antiderivative of expressions that we know no rule to find. Okay, let's start. Here's our first question. We want to find the derivative of x sine x. Hence, find the antiderivative of x cos x with respect to x. Now the critical word here is hence. Hence is a word that we don't use very often in English, but it means use your answer to part 1 to find part 2. So use your first answer to find the second answer. So let's start. Here comes, we started with function of x equals x sine x. We want to find the derivative of this. Recognize that as a product of a function by a function. So I'm going to let u equal x, v equals sine x. The derivative of u is 1. The derivative of sine x is cos x. So our derivative becomes sine x plus x cos x. So there's part 1. The derivative is sine x plus x cos x. Okay, let's start with that to do part 2. What have we just showed? We've shown that the derivative with respect to x of x sine x equals sine x plus x cos x. Now you look at this part of our question here and you'll say we wanted to find the antiderivative of x cos x. So what we're looking for is the antiderivative of x cos x. So what we'll have to do is take the antiderivative of each of these. Now the antiderivative on the left hand side and the derivative cancel each other out and we're left with x sine x. We don't have to do any mathematics for that because we knew that already, which means that we now have sine x dx and we have the antiderivative of x cos x dx. Our job now is to get this expression by itself, so I'm going to subtract x sine x. So I'm just going to bring this one over to the left hand side. X cos x with respect to x equals x sine x minus the antiderivative of x sine x dx. And let's work out what does that actually give me. Well, it gives me x sine x. Now the antiderivative of sine is minus cos, so that becomes plus cos x. And don't forget, this is an antiderivative, so plus c at the end. We're always going to put that plus c at the end to because this is an antiderivative. Notice what we did here. I'm just gonna change color on my pen for a minute. Oh no, I might even highlight. We had to find the antiderivative of this. We had to find the derivative of that, and we used the derivative. We used that answer to find the antiderivative of this, and you'll notice that's part of the answer. So that's the technique that we're using. Let's do another one and see what happens. So this is example 2. I'm going to find the derivative of log to the base e of 6x squared plus 1, and hence I'm going to find the antiderivative of 2x 6x squared plus 1 with respect to x. Now, the deal here, first thing is find the derivative. Function of x equals log to the base e of 6x squared plus 1. I recognize that as a function of a function. So I'm going to let u equal 6x squared plus 1, and y is going to equal log e of u. Then I'm going with, well, u dash equals 12x, y dash equals 1 on u. Okay, let's put all that together. The derivative equals 12x times 1 on 6x squared plus 1, which is 12x on 6x squared plus 1. Okay, there's our derivative. Now, the question, that's part 1. Part 2 says, hence, find the antiderivative. So we're going to flip over the page. No, we're not. I've run out of space on the next page. So we want to find the antiderivative of 2x on 6x squared plus 1. Now you look at our answer down here, and that's not quite 2x on 6x squared plus 1, that's 12x. So how are we going to deal with that? Well, let's see, what did we find? We found that the derivative with respect to x of log e to the 6x squared plus 1 equaled 12x over 6x squared plus 1. Let's take the antiderivative of both sides. If we take the antiderivative of this and the antiderivative of that, that kind of looks close to what we're looking for, but it's not totally the answer. This side becomes log e 6x squared plus 1. This side, if I take 6 out as a common factor, that becomes 2x on 6x squared plus 1 with respect to x. That is what I'm looking for. Divide both sides by 6. And that equals the antiderivative with respect to x. So it didn't come out exactly, the derivative didn't come out exactly to be what we were looking for, but not much had to change to make it into what we were looking for. Okay, That's integration by recognition. I now want to talk a little bit, the second part of this exercise has some integrations of functions that we don't have any rule for. So if you look at this one, 1 on the square root of x squared minus 1, we don't have a rule for that. So when we don't have a rule, we just throw it straight into our graphing calculator, put it in exactly as it seems, and the calculator will give you an answer. Sometimes your calculator will be able to help you with the answer, sometimes it won't. So if you're not sure, if you've got no clue, just put it in the calculator and see what happens. Okay, during this presentation you have been able to find the antiderivative of one expression by first finding the derivative of a related function, and use the CAS calculator to find the antiderivative of an expression for which we know no rule. Okay, done.